Hello, followers of my YouTube channel. Welcome to today's tutorial. Today I would like to show you some technical aspect on these soil and water conservation practice measures, using the SWAT model. Therefore, I have selected some literatures that helps us to know or to conduct the best management practices that helps us to reduce the soil loss from a watershed. Okay, therefore I have selected these two papers. Actually, the first one is this prioritization of subwatersheds to sediment yield and evaluation of the best management practice in highland of Ethiopia, actually done on Finch watershed. Yes, you can see the scholars here, and under this paper you can get that different best management practices. You see the best management practice scenarios. So before the applications of these best management practice scenarios, the SWAT model should be calibrated and validated. You should have to calibrate as well as validate your SWAT model, and after you are rerunning your model with the fitted values, you can proceed with that of the best management practice scenarios. Okay, that's the main concept here. So based on this paper, those researchers select around 6 scenarios, without the baseline scenario. Okay, so this is the baseline scenario, or scenario 0 is the baseline scenario. That means the base scenario was prepared by the actual or present condition existing in the catchment after you are calibrating and validating your your SWAT model. Okay, in the second scenario, they propose is a grass control strip. You see, so you can work on the filtro parameter, the USLE, universal soil loss equation P, yes, and the SL, that means slope length parameter, in the HRU SLP. Those parameters are touched in order to incorporate or do this scenario 1. So we have this the calibrated value. After calibration, we may get those values. So you should have to modify those values with this one in order to reduce, or in order to add this scenario 1, the grass control strip. Okay, and the other is also soil or stone bends are also provided under scenario 2. That is the curve number, the USLP as well is touched here, and similarly the SL sub-basin parameter are also touched. So we can have another parameter. Therefore, another scenario. Therefore, you should have to work how can we modify those values under SWAT model. Under a SWAT model. Therefore, we can incorporate and reduce or select the best method that helps us to reduce the soil loss from a watershed. Okay, the best BMP or best management practice that helps us to reduce the soil loss in the watershed. And the another interesting paper is about similar work, that is evaluating the effectiveness of best management practice on soil erosion reduction using the SWAT model, which is worked on Gumera watershed, upper Blue Nile Basin, and those are the researchers. And under this paper, they also takes around 1, 2, 3, 4, 5, 6, 7 scenarios, and this one is also the baseline scenario, in order to select the best one that helps to reduce the sediment loss from a watershed, from this Gumara watershed. And similarly, we can see that based on the description here, description of the considered best management practices and the parameter change in the SWAT model database based on the suggestions of literatures based on Lemma, yeah, Gatugu, Battery, Widler, Astras, and Daulacho. Based on those guidelines, or based on those reviews, they suggest or they modify the calibrated values of different parameters with this one, okay, with this one, and they select, or they finally suggest the best, or the best management, this soil erosion reduction measure, yes, soil erosion reduction measure in Gumara watershed. You can see under the result. I would suggest you to see those two papers if you are working on a similar areas. Okay, so you see here, this one is the baseline scenario actually, and it is a filter strip. When they apply, actually this one is the red colors are highly erodible watersheds, and if they incorporate this filter strip, those subwatersheds are changed to that of 1, 2, 3. Only 3 subwatersheds are still highly susceptible for erosion. But previously, under the baseline scenario, 1, 2, 3, 4, 5, the basins was susceptible to erosion. When they apply this SSB scenario, yes, soil bend, that means soil or stone bend scenarios, only the two subbasins are susceptible for erosion. And this GW scenario, you can read that in a similar way, similar with this one, yeah. The two subbasins are still susceptible. You see, similar cases are visible here, visible here. So they suggest they raise their suggestions, yeah, their suggestions. So the main thing here is, how can we do such technical aspects in a SWAT model? Okay, in a SWAT model. For this tutorial, let me use this review, yeah. Let me use this review, and let us add the first filter strip, and we have the baseline scenario actually. For instance, this one is a previous model what we have exercised in QSWAT, and you can also practice or see on ArcSWAT. So if you see here, the baseline scenario here is the baseline scenario. Here indicates that this red color, those subbasins are highly susceptible for erosion, yes, as we see here, because those are red colors. And the green colors here around the watershed, not this one, I hope, yes, yeah, subbasin 11, 10, 11 are somehow not susceptible to the soil erosion, yeah. Therefore we may incorporate those parameters. So to do this, the first thing what we need is SWAT editor actually. Okay, the SWAT editor. Let me open the SWAT editor, and let me connect to the database. Okay, first you should have to know the parameters, okay, the initial parameters for each parameter for the BMP, okay, the best management practice parameters. For instance, if you are working on filter strip, you see that the suggested one is the description. 1 meter wide grass strip established on the cultivated land. That means the calibrated one may be 0, so you should have to modify by 1 meter width grass strip. Okay, after that we can analyze the impact of this filter strip. Okay, so to do this you should have to proceed to this SWAT editor, and those parameters are available under sub-basin data. Okay, so for the case of filter strip, actually this one is you should have calibrated the model as I have told you before. So let me select the management and can select the sub-basin here. You can select the land use, soil, the slope, say OK. Okay, so we have this one. So for the case of filter strip, you should have to touch this filter, yeah? So you should have to edit value. Now the inactive cells are now active. Okay, so for instance, for our project, sub-basin 3 and 6 are highly susceptible for erosion, yeah? And if you proceed with the remaining sub-basins 2, 5 and 7 are also susceptible, yeah? Therefore we can proceed or work on the 1, 2, 3, 4, 5 watersheds in this robit watershed. Therefore the first thing that you should have to do is you should have to know the initial value for the filter, because you should have to adjust in each BMP or best management practices, or you should have to copy your working folder into another directory. That means by default my working directory is located on this A under QSWAT. So you should have to copy this, and you should have to place your this project to your hard disk or another place. After that you can analyze your work. So let me use the initial values is this one is 0, so I can change to 1. Yes, and extend your value, extend it to selected HRUs, and as I have told you before, the values I would like to reduce the sediment or the impacts of this filter strip on the sediment reduction on sub-basin 2, 3, 5, 6 and 7. Therefore under this sub-basin you should have to go to 2, yeah, then should have to know 2, 3, yeah, 2, 3, 5, 6, 7, yeah. You can select by pressing Ctrl, yeah. By pressing Ctrl you can select those sub-basins. I would like to reduce the sediment under those highly eroded subwatersheds. And on the land use we can select all land use. Yes, all land use. Actually on these 5 susceptible subwatersheds, the land use type is, you see, agricultural land only. So therefore you can select the agricultural land. You see how the agricultural land are highly susceptible for erosion. It indicates us. And the soil is all soil type and all soil. Actually we have this land use, I mean soil, and this slope. You see those under those subwatersheds, the soil type is this LVX, and the slope is between 5 to 15%. Yeah, so you should have to see those things. After that you can say that save our edit. Yes, we have now saved our work. Okay, so after that we can run our model. Okay, so the first thing, not run your model, but you should have to rewrite your work, rewrite the management parameter, because we have touched the filter, yeah, FS, that is the filter strip parameter. So write it. Now it is done and can cancel. So let me run my model. Okay, in order to save time, sorry, you should have to select the processor version for your computer. For my case, 64-bit release, and I have provided 2 years for the warm-up period, and set SWAT model or a SWAT run, and let me run the SWAT. Yeah, so you see our model successfully runs, and let me read the SWAT output. These parameters import file to database done, and I would like to say that that means BMP based management practice, which is the filter strip. Okay, say save. Now we have successfully saved our work. Say OK and cancel. Therefore, my thing here is you can visualize our work in 2 ways. We can proceed. The first thing what you can do is we can proceed to this QSWAT practical when, and we can see under scenario that is a BMPS FS, and we can see the table out. Yeah, under this we can see the sediment reduction as outlets of the watershed, or still on this SWAT. Okay, still on this SWAT, you can open this and say visualize, and I would like to visualize the sediment based on the best management practice with filter strip, and actually the sediment is available under subbasin. Yeah, under the subbasin. And to reduce our time, let me see with 3 years data the sediment from 1993 up to that of 1997 for our time. And under this choose variable, you can select the seed out. That means sediment yield in ton per hectare. Say add here. Okay, select it and create. Alright, so let me see now. Okay, you see previously on the baseline scenario, the sediment, the maximum sediment is around 580. Yes, but by applying this filter strip on that of the baseline scenario, we have reduced the sediment to 370. Yeah, and now we have subbasin 3 and 6. Subbasin 3 and 6 are highly susceptible still, and you can apply another measures. Okay, I hope you have seen some highlight here how those best management practice reduces the sediment in such a way. Okay, therefore we can work on that, or one thing, as I have told you before, let me open this one. Okay, and let me enable this one and go to the subbasin data, and I would like to see for the year 1993, 4, 5, 6 and 7 for those 1, 2, 3, 4, 5 years data, and I would like to work on that. Okay, in order to reduce our time and see the sediment. Okay, you should have to paste here, and we have this one. Okay, so after that we can this one is actually on the sediment yield. Yeah, we have this one. Okay, so I would like to know the sediment. Okay, so let me remove those things. Yeah, for our case, delete this one, and as well this one should have to delete this. and you see, so we have subbasin, yeah, the year, the months, and the sediment. Those columns, go to this insert pivot table. Now I would like to visualize the data. Yes, under this this worksheet, under this one. Okay, say okay. And my case here is a subbasin here. Okay, and my content value here is sediment yield, and I would like to see the average value. For instance, that means I would like to see the average. You see, the average value here is from between this the year 1993 up to 1997. For the subbasin 1, we have this one, 2.79. Yes, and from for the case of 2, we have this one. This is for the case of this applying the FS or filter strip. Okay, so if you see on the baseline scenario, let me compare that value. Yeah, from the baseline scenario, we can see that the sediment yield may not be equal with this one. Yeah, so basin, then the year is we're 93, 4, 5, 6, 7. Okay, so okay, copy this one in a similar way, and let me open a new sheet here and paste here. Okay, so similarly, let me delete those values. Okay, delete this one. Okay, now I have also delete this one. In a similar case, let me select those values, insert pivot table, and this existing worksheet under this one, let me select, and let me see the sediment yield similarly with from the baseline scenario. So this one is average. Okay, you see now. Okay, so therefore let me copy this one and come back to sheet 1. Let me compare the values. Okay, paste the value here. Yeah, and for the case of the this one is actually for the baseline scenario, baseline scenario, and this one is for the case of filter strip. Yeah, so we can copy this one and paste the value here, and let me insert here. You can see that, you can visualize here on the baseline scenario. For the case of the basin 2, the sediment yield is this one, because we are working on the basin 7, I mean 2, 3, 5, 6, 7. Yeah, those values are very high. For the case of I mean, we have working on 4, 6, 7. Yeah, 2, 2, 3, 4. Yeah, 2, 3, 4, 6, 7. So those sediments are reduced to this value by applying this filter strip. Okay, so it's very important to analyze your work in such a way by applying these best management practices. Okay, let me add one more this best management practice. Okay, so to do this, the first thing is you should have to go to this SWAT editor. Okay, SWAT editor, and from this literature, let me add one more thing here. For instance, a stone or soil bend. Yes, stone or soil bend scenario. So to do this, you should have to touch the SL. Okay, SL and a HRU value, as well as a curve number and universal soil P. So you should have to touch those parameters, but you should have to work on the original baseline scenario. Yeah, so you should have to work on the original baseline scenario. That means if you are copying to another directory or C, it may be, so you should have to work on that, not on the filter strip uh, uh, model. Okay, so you can work that. So if I check this, the management one, okay, we can have an access. Okay, so we can get additional parameters. Therefore, in order to get this SLB subbasin parameter, okay, for the case of stone or soil bends, this SLSBSN, you should have to go to this. Actually, on the we have also on HRU. Let me see on HRU. So on HRU, yeah, we have this SLSU. Is it SU? Yes, is it SU or yeah, SUBBSN, yeah. So we can work on this one thing, and the other is also the universal soil laws P, yes, and the other thing is HRUSLP. You can also check those universal, this one HRUSLP, curve number as well. The curve number is under management. We can work on that. Therefore, if the initial value is A, or the calibrated value is this one, so you can modify by multiplying with 0.5. That means you can take half of this one, and for the case of HRUSLP, you can multiply this value with 0.75. That means you should have to reduce the previous value by 25%. Okay, you should have to reduce by 25%, and you can provide that. And the default parameter is actually for this research is this one, and they substitute by this one based on those reviews. Okay, and for the case of SLP, the initial or the calibrated value is this one, and provide with this one. Okay, therefore let us provide this SSB based management scenario. So the first thing is SLB, so you should have to edit this one, and this value should be half of that one, yeah. So half of this one means around 30.5, let me say 30.5, and this one should be multiplied by 0.75. That means let me use this Excel. So this one equals 0.75 times this value is how much? This value is 0. This one. Actually, let me copy this one and come back to easy here and paste the value, enter. So you should have to copy this one, copy the value here, and come back here and paste the value. So this one is a modified value. So we have obtained two parameters, okay, and the other parameter for this case is the curve number, and let me use this universal soil laws equation P. Okay, so go to this one. Is there anything here? Okay, so we can extend this. We can extend this similarly for the case of the previous subwatersheds, yeah, 2, 3, 4. I think, and 5, 6, 7. Yeah, should have to select in such a way. 5, 6, 7. This one, 2, 3, 4, 5, 6. I mean, sorry. This one should have to press Control 567 those parameters, this one, save your edit. Okay, so actually unhandled exception has occurred in your application. If you click continue, the application will ignore this error and attempt to continue. Yes, we should have to continue, and should have to continue. Yeah, so we can exit this, and let me also provide the management parameter, that is the curve number. So edit this value. The default parameter for this paper is actually 78, and they provide 59. So let me provide this 59 for the curve number. Yes, 59. Sorry, 59. And for the case of universal soil P, the default value is this one. I mean the calibrated value, but they provide this one 0.32. So let me provide this 0.32. Okay, as I am showing you as an introduction. Should have to work in detail. Okay, so you should have to make in such a way and extend it for the sub-basins in such a way. Yeah, in agricultural land, this soil, this slope. So save edit. Okay, now it is saved. So we are now editing our parameters, and the other thing you should have to do is also you should have to rewrite your work on the HRU in the management. You should have to select those HRU in the management parameter and write your work then. So now let me run our model in a similar way. Let me use this one. Set up your model here, run SWAT model. Now you are working with, and the other thing is you should have to read your work here. Say import file, done. And this one is soil or stone bend actually, and that is sorry, we can say that best management scenario, the best management practice. Okay, underscore SSB. Okay, save your work. Okay, so to see the impacts of this best management scenario in a similar way, you can proceed to this SWAT, yeah, under this visualization, and choose a scenario. The scenario is actually we can, let me close this one and reopen it. Okay, the best management practice SSB, and under sub-basin I can also check for the 5 years, that means up to 1997, and I should have to select the sediment here, add, select this sediment yield in ton per hectare, and say print or create. So if you see here, if you see your SWAT model, now we are closer to eliminating highly erodible subwatersheds. You see, based on this soil or stone bend sediment management practice, the maximum sediment is around 344, and now still it is reducing from that of the field strip. Okay, now we have this one is better than that of this one, since it reduces the sediment. Okay, so actually we can see in such a way. Okay, so we can also visualize under Excel. If you see here average value, average sediment yield, okay, from the total one, you can get that. You can see this one is actually the baseline scenario, but this one is with applications of field strip. Let me see with SSB. Yes, let me see with SSB. Go to this folder, come back with this one, yeah, text out, and go to this SWAT output. Okay, and we have this one under the basin. Let me select the year from 1993 up to 1997, and let me copy this value here, and let me open another sheet. Yes, paste your value here, and let me delete this one in a similar way, and also the remaining data, since it's not important for my case. So we have those values. Yeah, we have these values, and I would like to work in this existing worksheet under this one. Say OK, and let me select the basin under the row, sediment yield in ton per hectare under the value, and select as value a varied value here. So we have this one. Now we can compare the value. Copy and go to sheet 1 and see the value here. Okay, value, and we can see. You see, this one is actually the baseline scenario. Yeah, for the case of baseline scenario, this one is the baseline scenario, and if you are applying this filter strip, we are reducing the sediment into this one. The average sediment from each basin is 3.98, and with that of the applications of SSB, we can have a sediment of this one. Therefore, this SSB reduces the sediment in such a way. Okay, we can get the in percent. For instance, we can have the sediment reduction in percent. For instance, for the case of this SSB, this one, yeah, actually, or we can say that this one minus this, yes, divided by the initial or the baseline scenario, we can have this one. That means if you multiply it with 100, we can get that from the around 66%. And in a similar way, we can also see that for the case of this filter strip, we can say that from this minus this one divided by the original value, we can get that this one also reduce the sediment by 25%, okay, from the baseline scenario. Therefore, we can work or we can apply these management practices in order to select the best one that helps to reduce or that helps to minimize soil erosion from a watershed. I hope this tutorial is very interesting, and you have should have to work on that by using the SWAT or QSWAT model. Actually, this QSWAT model is very interesting. You see, you can visualize once such things, yeah, and I hope it is very important for you. And practice on your own by searching those interesting papers. And it is enough for today. And don't forget to subscribe and to share my YouTube channel as well. Have a nice time. Thank you for your time.